Teaching assistants are often expected to help students learn. But what does learning look like? How can we tell if students have learned something? And how do we know if that learning meets our standards? We can't look inside our students' heads and see learning, and there is no machine which reveals it either. To check whether students have learned what we want them to learn, we must ask them to do something with it. They have to demonstrate that they have integrated it. A common way to do this is to ask questions, either verbally in class or in the form of an examination. Here, they have a chance to demonstrate their knowledge. Another way to get students to display their learning is to give them a specific task, such as an experiment to complete, an equation to solve, a project to design, and so on. In order to make learning truly visible, though, we first have to define what outcome we want. Here, the most important question in your teaching should be, what do you want students to be able to do by the end of your class? This is knowledge in action. Instead of simply listing what you want students to know, you should list the skills and behavior you want to see. This gives both you and your students a clear picture of what is expected of them. The elements you list are what we call learning objectives, and they are the basis of every class. Lecturers write down the learning objectives for the entire course, and it's the job of TAs to break them down for the lesson plans of individual classes.
The teaching assistant.
A good learning objective will state both the skill that the students are expected to acquire and the level of complexity that skill should have. Let's look at an example of a lecturer's general intent and then construct a specific learning objective out of it. By the end of this course, students will have learned about the programming language Python. This sentence only states that the expected outcome is for students to learn about the programming language Python. It does not mention what they should be able to do. But maybe we know that actually they should not just learn about Python, but understand its function and how it works. Let's change the sentence to, students will understand the programming language Python. But there's still a problem. How do you demonstrate understanding? The verb understand is not specific enough. What if we change the sentence to, students will be able to write programs in the programming language Python? Now we have a learning objective. We don't just want students to learn about or understand Python, but to write programs in it. That is, do something, which we can check and validate. Do you see how the trick is always in the verb? We might even go further. Writing a program in a programming language is general and has nothing to do with Python's specific functions. A more targeted learning objective might be, students will be able to write simulations in the programming language Python. Now we have a true learning objective. If, at the end of the course, students can write simulation code in Python, they will have succeeded in learning and understanding Python, just as we wanted. They will have met the learning objective of acquiring knowledge and putting it into practice. Now, this may sound like a lot of work for a TA, but learning objectives have real, tangible advantages. First, learning objectives describe what the course is about, for both teachers and students. With a good learning objective, everyone knows in advance what the goal of the lesson or course is. It sets expectations, like a sort of contract. Second, learning objectives shape how a course is examined. Performance assessments should always be aligned with the stated learning objectives. If you want students to know how to program in Python, that's what you should ask them to do in the exam. You might add specific things they should be able to program in Python. The exam becomes a graded opportunity for students to demonstrate in action that they have met the learning objective. Third, learning objectives are a really helpful teaching tool because they help you to plan learning activities. Think of it this way. Your students know the learning objective and know that later the performance assessment will show whether they've achieved it or not. In between, they need practice and a chance to get feedback on their progress. The learning activities you give them are important practice opportunities that show them whether they're on track and where they are in relation to their peers and your expectations as a teacher. Research by Biggs and Tang in 2002 showed that student learning is affected much less by what the teacher says than by what the student does. A teacher can lecture all day about playing basketball, but if she never hands the ball over, her students will never learn how to play. Therefore, the activities you organize for your students should be based firmly on the learning objective. In our programming example, the learning objective was to write a simulation in Python. Your job is to break the objective down into smaller sub-objectives, meaning the individual steps needed to achieve the greater objective. For example, knowing that most simulations require loops and that they are a control structure in Python, your goal for a day might be, at the end of today, students will be able to program a loop in Python. This is where your experience comes in. Think through the task and define the key steps in it. Where do you anticipate difficulty? Have the students ever written a program? Do they know what a control structure like a loop even is? To fine-tune your activity, you may need to ask them about their prior knowledge. Now that you know your day's goal, you can plan your lesson. The lesson's learning objective: program a loop in Python, because that's what you need to program simulations. Learning activities: explain the use of a loop. Demonstrate a loop in action. Discuss it. Get students in pairs to write a little program that counts to 100 in steps of 2. Walk around and give them guidance, etc. Assessment: does the program work? Does it do what it should? Now, make the program count backwards. Can students do that alone? Ensuring that learning objectives, learning activities, and performance assessment all correspond is called constructive alignment. With your learning objective, your lesson more or less designs itself. You know the goal and can work backwards from it by aligning activities and everything else. The objectives, activities, and performance assessments should all have the same level of complexity. It's not fair to students if you surprise them with an exam question which is harder than what they practiced in class. Thus, learning objectives become guiding statements that help you to keep all input, activities, and performance assessments on the same track. When you plan your classes, always ask, will this help the students reach the learning objective? If the answer is no, do something else. In summary, learning objectives will help you to head, with your students, towards a defined, verifiable and achievable goal, in aligned steps and without random detours. When the learning objectives are reached, you can all celebrate together.